This video is for section 7.3 and we are starting off with example number 4, which is the same as your homework problem number 4. So on this one, first thing that I want you to notice is that my tablet's not working. Alright, there we go. There we go. Alright, so first of all, we have an equation. We've got 4 cosine 2 alpha is equal to 4 sine squared alpha plus 1. So kind of like an equation, almost like a quadratic equation, but it's not. We've got sine squared and we've got cosine of a different angle. So let's look at the formulas that we've been using. We've been using the double angle formula and we've also been using the half angle formula. So cosine of 2 alpha, that seems like a double angle formula to me. So what are our options for replacing that cosine of 2 alpha? Because the cosine of double angle is the one that gives us 3 different options. So we could do cosine squared A minus sine squared A. That's not going to really help us because then we're going to have a cosine in there that we're not going to be able to get rid of. We could do 2 cosine squared A, but then again we still have cosine and sine. So let's try with our last option, the 1 minus 2 sine squared A, and go with that. So I'm going to do a substitution. Instead of writing cosine of 2 alpha, I am going to write 1 minus 2 sine squared alpha. And that is using our double angle identity. And that is all equal to 4 sine squared alpha plus 1. Now, be careful not to be tempted to divide by 4. If we do divide by 4, we would have to divide this 1 by 4 also. So it is doable, but it's going to leave us a fraction there, so not necessary. Now I want to get rid of the parentheses on the left-hand side, so we're going to multiply that 4 through. So I'll have 4 minus 8 sine squared alpha equals 4 sine squared alpha plus 1. Okay, I want to combine like terms now, and actually why don't we just go ahead and get this equation equal to 0 as well. Let's just combine like terms. So we've got 4 equals, we're going to add the 8 sine squared alpha to both sides. And that's going to give us 12 sine squared alpha plus 1. And now we want to solve for sine squared alpha. So let's subtract 1 from both sides. And I'm going to turn that around just because I'd rather my sine be on the left-hand side. So we have 12. That door's locked for a reason. Go round. Okay, sorry about that. Back to what we were doing. All right, I want to write my... oh, that's not very nice. My sine on the left-hand side. So I have 12 sine squared alpha is equal to, what I do, subtract 1 from both sides, so I have 3. And then divide both sides by 12. And then we have sine squared alpha is equal to 1/4. And then we're going to take the square root of both sides. So the square root of sine squared alpha is equal to, and don't forget this plus or minus, or you will miss half of your points. So sine squared alpha, and the square root of that is going to be sine alpha. And then that is going to equal plus or minus the square root of 1/4, which that's going to be plus or minus 1/2. So we want all of those values on our unit circle. So we've got our unit circle. Okay, so where sine is going to be positive 1/2 up here, and sine will be negative 1/2 down here. So we've got 4 different positions that our sine could be. So that means we need to find 4 different angles, and we'll have 4 different solutions. Okay, so this is going to occur at pi over 6. This one over here is going to be 5 pi over 6. 7 pi over 6 down here, and 11 pi over 6 here. And those will be all 4 of our solutions. Okay, and we will move on to example number 5. Example number 5 wants us to use a half-angle formula to fill in the blanks of this identity. Now, there should be one more blank in here, actually, because there's going to be a coefficient to this cosine value also. So we're really not going to use that information, but when you look on My Open Math, there should be a blank there in front of the cosine also. We also call this an power reduction. And they do have power reduction formulas, and those formulas are just different versions of the double angle formula and the half angle formulas. So it's using the same information that we have. So we are not making you memorize another equation. We're just going to show you how to do a power reduction using a half angle identity. Okay, I'm back again. All right, so power reduction rule. So notice on this left-hand side that we have a cosine squared term. On the right-hand side, we're going to have no squared terms at all. So this is what we mean by power reduction. We went from having a cosine squared to having just cosine to the power of 1. So first of all, let's go ahead and look at our half angle formulas, because they specifically state they want those half angle formulas. You can also do this with a double angle formula. I've done it both ways. It is actually easiest to do it with the half angle formula. The only thing we really have to do at the beginning here is make sure that we rewrite this so that it's in form of a fraction. So we want to write 8x so that it has a denominator of 2. So just by using your laws of fractions, we can rewrite that as 16x over 2, and I hope everybody understands how we did that. Just multiply top and bottom by 2, and you now have a fraction with a denominator of 2. Other thing is we need to look at that half angle formula. Well, the half angle formula on the left hand side, it is the cosine of 2a. So, oh no, sorry, not the double angle, half angle formula. Look at the half angle formula. It is theta over 2. So in this case, I'm going to always write out here in front what theta equals. Theta is going to equal 16 over x. So just looking on the inside, don't worry about the square. I know that that's not in the formula, but we're going to work with that. Just look on this inside. We have cosine of 16x over 2. So therefore, theta is equal to 16x. Now we're going to use that theta when we go through our formula. So the formula for the half angle identity of cosine is equal to plus or minus the square root of 1 plus cosine theta over 2. Now one other thing that's happening here, that works for the inside. Oh, I just did what I said we had to be careful with. What do we want this theta to be? This theta is now 16x. Okay. So we need to make sure that those match up. So that theta, that's why I wrote this theta out in front, so that I would remember to write it there. A lot of good that did me. Okay, and so also, that matches the inside of our parentheses. Also notice that we are squaring our cosine, our half angle identity. So let's continue this on. When we square that, our plus or minus goes away. We no longer have to worry about that plus or minus. And also the square root goes away. So now, and I'm going to write it as a separate fraction. So 1/2 plus 1/2 cosine of 16x. All right, and then you're able to fill in your blanks. So we would have a 1/2 here. I should have another line here, which that one would be 1/2, and then we would put 16 here. And that's all you need for number 5. All right, example number 6. We are given an equation, sine of 2x to the 4th power this time, and they want us to expand it to this format. So first thing I want you to notice is that there is no exponents. So we are going to have to be using this power reduction formula, or I should say using the half-angle formula to reduce power. The last one we did was a squared function. This one is to the 4th power. So what this means is we're actually going to have to use this half-angle formula 2 times to make this work out correctly. So we're going to start off by looking at your identity sheet, and we want to use the half-angle formula because that's what they tell us right here. Okay, so we want to use that half-angle formula. So we need to rewrite this equation so that it's in the format of a half angle. So that's going to be 4x over 2. And then that's to the 4th power. And then again, I'm going to write my theta out here. Theta equals 4x. And I'm going to really try hard to make sure I use that theta equals 4x. So using my identity sheet, I have the sine of theta over 2, which our theta is 4x, is equal to plus or minus the square root of 1 minus cosine, and instead of theta we're going to write 4x all over 2. Ooh. And then that's all to the 4th power. So when we raise that to the 4th power, we're going to get rid of the plus or minus. We're also going to get rid of the square root. I'm going to write that out so that it's 2 separate fractions. So 1/2 minus 1/2 cosine of 4x, and it's still going to be squared because remember we've got to the 4th. So the square canceled with the square root, but we still have another square in there. Now when I square this, I'm going to use that quadratic property. Come on, work here. Why are you doing this to me? Hold on. I gotta get my... Alright, so we're gonna try to rewrite that a little bit nicer. Boy, my pen is really giving me fits. Okay,